Hi all, this is Thomas from NetTime Logic, and in this video I will show you how you can initially program the FPGA of the timecard. Here on the desk you can see now two different kind of JTAG programmers which you could use to program it. The first one is a white one, it's one from AliExpress. It's a quite nice one. It has an adapter print which allows a lot of different possibilities of cabling. Here I have now installed the cable which directly fits also to the connector of the timecard. The second one which I have here is the one from Xilinx. Xilinx is also the company which provides the sum module which you can see here for the timecard. They have also some kind of evaluation kits where you get directly this JTAG adapter, but you can also order it separately. It has also directly the matching connector, which fits the connector on the timecard. On the timecard itself, you can see here directly next to the GNSS module, the white connector, which is connected to the JTAG interface of the sum module. As a next step, we can simply now connect the JTAG adapter to this interface here, install the timecard in our PC, and boot the PC to program later on the FPGA. The timecard is now installed on my lab PC, and then I'm back on my working station, which I will use also to program the FPGA of the timecard. Here on the right side, I'm back on GitHub on the Time Appliance project in the open source implementation Xilinx timecard folder, where you can also find the Readme, and in chapter 9 is basically also described how you can program the SPI Flash of the timecard. Before we are starting programming the FPGA, I would like to show you again the different kind of output products which we have created during our implementation run. For that reason, I go into my local repository, into the folder FPGA, open source, implementation, Xilinx, timecard. And here we have the folder binaries. In the folder binaries, we have now a couple of files. On one hand, we have bin files like the factory timecard os.bin or the timecard os.bin. On the other hand, we have a bit file. The bit file can be used to program the FPGA directly. In that case, we are writing it into the configuration RAM of the FPGA. This also means that the configuration is volatile. So in case of a power cycle of the FPGA, the configuration gets lost and we are loading again from the SPI Flash. So this case is only intended to be used for debugging purposes or some testing. I would really not recommend to work with the bit file, but for some testing it might be helpful because it's much faster to program the FPGA. The proper way will be to program the SPI Flash. For that we have the bin file. This is really a binary file with no additional header information, so it's a raw file which you can directly write into a flash. As already mentioned in my earlier tutorial, the factory image is the one which contains a golden image and an update image. So this is the one which we will use to program initially the timecard. So now, as a next step, we can go to Vivado and open the hardware manager. This would open directly the menu where you can program the SPI Flash or the FPGA. But you can also open our already created project via the tickle script. This takes now a couple of seconds until the project is loaded, but as soon the Vivado project is ready, we can also go into the hardware manager. So now it starts to open it. Now we can already see the project view, and we have here the option to open the hardware manager. So click on Open Hardware Manager. This loads directly the hardware manager view, and now we can go to Open Target and click on Auto Connect. This has now detected my JTAG adapter here. Connected to this JTAG adapter an RTX 700T device, which is the FPGA on our timecard. As you can also see, it's not programmed yet, so it's a brand new timecard which I have in here. Now you have the option to right-click on this device here. Then you can select Program Device. This would allow you to program the bit file. So I can go back here to my binary folder where I have my timecard os.bit file, and I could now program this bit file directly into the FPGA. As already mentioned, this would be volatile. So as soon as I do a power cycle, this configuration gets lost and the FPGA is not programmed anymore. To demonstrate how does this work, I will now click on program. It's a quite fast process, so it takes just a couple of seconds and the FPGA is programmed. In case I would like to use now this programmed FPGA device, I have to restart my PC. This is required to re-enumerate PCI Express, which only happens on a restart, but it's only possible with restart because if I shut down the PC completely, we would lose the FPGA configuration, and then enumeration of PCI Express would still not work. So only a restart would now help to start working with this time card as it's programmed now. But the main idea is to show you how to program the SPI Flash, so to really configure the time card correctly. For this, you have to right-click again on this device here and select Add Configuration Memory Device. This opens up a view where you can add a configuration memory device. Now I will go quickly to my cheat sheet. So here you can find it on chapter 4. Which device we have. I just take it and paste it in here, then I can select it. And it asks me directly if I would like to program this configuration memory, and I click here on OK. Now I can select here the corresponding image. It's very important that you now here select the factory timecard os.bin image. If you flash here the timecard os.bin, which is only the update image, you have not the field upgrade feature, which allows you to make fail-safe field upgrades with this approach of a golden image and an update image where you have two different kind of sections in your SPI Flash. The factory image contains both of this image, so it contains the golden image and the update image, so it's really the image which is desired to flash initially on the timecard. So I will select this one. On the other settings, I have not to change anything, so I will initially erase it, then program it, and do a short verification. As soon as I click on OK, it starts to erase the flash. This will take a couple of time, programming as well. Let's start the process. So now the process has started, and it will take a couple of seconds or even up to a minute, and I will be back as soon as it's finished. As soon as you see the message flashing programming completed successfully, the flashing of the SPI Flash is done. This doesn't mean now that the content of the SPI Flash is already in the FPGA. So to load now the FPGA with the content from the SPI Flash, you have two options. One option, and the most proper option, is to just shut down the PC completely and start the PC again. Not a simple restart, it must be really a power cycle. Alternatively, you can again click on the FPGA device here in the hardware manager view, right click and say boot from configuration memory device. This initiates again a load from the SPI Flash. If you do that, a restart of the PC would be also sufficient. So I can do that quickly and you will see it goes quite fast and still tells FPGA programmed. So now the target, the FPGA is ready to be used, and now I wish you a lot of fun to play around with your time card. Thank you for watching this video and see you soon.